And we'll go back to Gazzaniga now. And here's his evolutionary hypothesis about language lateralization and the effect that that had on human thought. And so here we've got the brain moving through time from left to right as humans evolved. That there's a strong role of language in the left hemisphere now. Okay, so but it started off when we were early primates without language. Both halves of the brain are doing the same sort of thing. They're doing perceptual grouping processes, recognizing things in the world around them, creating forms out of entities and recognizing patterns. At some point in our evolution, there were some mutations that affected the way that the left hemisphere developed. And that led to the beginnings of language. Once you've got language, then that dominates processing in that half of the hemisphere and allows you to name things and think about things in abstract concepts. And that, in fact, is the basis of what language is, giving a name to something, thinking about it when it's not there, recognizing its persistence when the lights go out, enabling those little shrew-like things to survive in the jungle. The right-hand brain stays as it was in our early unevolved state. Now, if you've got language dominating processing in the left-hand side of the brain, it doesn't completely extinguish all of the other perceptual grouping processes that were going on, but it dominates them, so it drives them down. There's less capacity left for them, and anyway, the language is being done there. Whereas the right brain is carrying on with all those perceptual grouping processes. So what you've got is a right brain with no language, and a left brain still trying to do the right brain tasks, but having language as well. But Gazzaniga said, if this is correct, then we might be able to find that any task that doesn't rely on language for its solution, or analysis, or labelling, or abstract thought, should be faster in the right-hand side of the brain, because it won't be interfered with and slowed down by language trying to get in the way. But this is the background behind that quote I showed you earlier, that the disconnected, mute right hemisphere is much like a chimpanzee, in fact inferior to a chimpanzee, because chimpanzees have continued to evolve since this happened to us. But the right-hand side of the brain on its own, without language, is just doing that early perceptual grouping processes. And an analogy Gazzaniga has with memory is that if I ask you about something, if your left brain is doing the processing, then it can do all the semantic analysis. I can ask you, can a bird fly? All of your knowledge and facts and associations about birds and wings and feathers and flight, and insects can fly too, but they're not birds. And all of that processing happens very quickly and rationally. Whereas the right-hand brain is done on patterns. So if I ask you about a bird flying, you might just sort of think about all different sorts of birds, episodic instances, anecdotal instances of birds. But what the right brain is very good at is remembering what you were doing on a particular day, perhaps. So here, he's been asked, what happened on September the 9th, 1999? It's like he's got episodic memory there. Oh yes, well I went out for lunch with Anne, and then on the way home I picked up some dry cleaning and I bought some stamps. And that's not the sort of thing that the left brain could do, picking out from contextual cues a pattern for the day. Now, one of the attributes or functions of the right brain and its perceptual processes, it's been argued that the right brain is better at processing face recognition, identifying emotions from faces. And here's an experiment from 2002 carried out by Compton, in which they explicitly used the fact that presenting things to the left and right-hand side of the fixation cross can send them to different hemispheres, to look at the ability of the two hemispheres to make matches between different stimuli, either on the basis of their physical appearance, are they identical, which is something that the left brain won't be able to do as well as the right brain, or on the basis of emotion. Are these pictures showing the same emotion, which is hypothesized to be a right brain function. And the way these experiments worked is you can see one of these two slides, you might see, you'd be asked to look at the fixation cross, and then these faces would all pop up. And so you've got two at the top and one at the bottom, which can either be on the left or the right. And your task either is to say whether the one at the bottom matches the person, one of the people at the top, just say yes or no, or does it match in terms of the emotion, one of the pictures at the top. So here you can see someone smiling, but it's a different person to the two faces at the top. So if you're asked, is it the same person, you'd say no, whereas if you're asked, is it the same emotion, you'd say yes, because he's smiling, so is one of the ones at the top. On the right, we've not only got the same person, we've got the same emotion, so you'd say yes to both. And in fact, this one is what's known as a structural match, because it is actually the same picture. So the left hemisphere should be really good at this one, same. Not much processing to be done there. But of course, by presenting the bottom one on the left or the right, if you're looking at the fixation cross, you know which hemisphere is doing the matching task. And you can also control whether the one it matches is on the right or the left as well. So you can either make all of the relevant processing happen in one hemisphere, or both hemispheres need to be used and communicate with each other. And here's a graph showing what Compton found. And the first thing is, what's on the vertical axis here is percentage correct. And so you can see that the lines are higher for the physical matches. When you're just saying, yeah, it actually does match. It's the same as one of the pictures on the top. That's very easy. And in fact, there is, though, a difference between the blue column, which is the left visual field, which has gone to the right hemisphere, and the red column, which is when the bottom stimulus is in the right visual field and has gone to the left hemisphere. So we can see that, yes, the right hemisphere does have an advantage, even on doing the physical matches, identifying that this stimulus is correct. When you get to a category match, however, where you've got to understand what's in the face, is it matching in terms of smile or actor? Is it the same person? Well, we're slower overall, but you see there's no difference between the visual field that the bottom one is presented to. So here we've got the right hemisphere has a benefit just to say it's the same stimulus. But that the hemispheres are performing identically when you've got to identify the person or recognise the emotion. So this doesn't support the idea that the right hemisphere is better at face processing. In fact, a more interesting finding that Compton found was when the match was between pictures that were on the same, processed in the same hemisphere, or pictures that were across the fixation cross and therefore processed in different hemispheres. Remember, this is within normal people who've got normal brains connected by the corpus callosum. Again, physical matches are better than category matches, seems correct. But here the blue line is when you're doing it across the fixation cross, using both hemispheres. And the red one is when both faces are shown in the same hemisphere. And you might expect if things are shown in the same hemisphere, both faces are there in the same place. It should be easier to process them. No communication required between these two hemispheres. Actually, it's better with the across hemispheres, more correct when they're shown on different sides of the visual field and the two hemispheres have got to exchange information. Why is that? Well, it's because they can work in parallel. Both hemispheres can do the same processing task at the same time and have just got to communicate the result. So they're better working in tandem, using both sides of the brain to do this face perception task than just using the right hemisphere alone or the left hemisphere alone.